We have a position versus time curve that we would like to translate into an instantaneous velocity versus time curve. Notice that this is a smooth curve. There are no corners or sharp angles on it anywhere. Our next example will have corners, so we'll see what the consequences of this smoothness are. First thing you want to do is look at your curve and break it up into segments that you recognize. We have a first segment here. The curve is flat and it changes right about there and it starts curving upward until there. Then it starts, we see we're slowing down, we're flattening out until about right there. Then we're speeding up in the opposite direction until about there. Then cruising along until here, straight line, and then another curve where it flattens out until there. Then it's speeding up down this way until about there, and you see it changes to start flattening out until there. All right, we've got our segments identified, and now you know how to translate each one of these segments into part of a velocity curve. First one here, we can tell definitely that we are starting at rest. We have a horizontal line, position is not changing. So we're starting from rest. Our initial velocity is 0, and up until this point right here, our velocity is 0. Okay, we're at rest that whole time. Then we start speeding up. There's our horizontal tangent right there because we start from rest, but by this point here, our tangent line has a positive slope. We're moving in the positive x direction. So we're speeding up from 0 to some maximum positive velocity right there at that time. But then beyond that time, it looks like we are slowing down. Draw in your tangent right there, and you see we've reached rest by this time here. So from our maximum positive velocity, we're slowing down to rest right there. So we can connect those 2 points. All right, we sped up to a maximum positive velocity and then slowed down back to rest, here to here. All right, beyond this point, it looks like we are speeding up again, but in the negative x direction. Drawing our tangent, this is a negative slope right here, so by this point we are moving in the negative x direction. We've got a negative velocity. So down here we've got a negative velocity at that time, and I can connect that line right to there. So this whole line segment here corresponds to this arc, showing that we have a large positive velocity, then we're slowing down to rest, and then we're speeding up in the negative direction to reach a large negative velocity right there. From here to here now, we see that we're moving at a constant velocity. It's a straight line with a constant slope. The slope at that endpoint is the same as the slope at that endpoint. So we have a negative velocity that's not changing this whole time. So our velocity is constant across that interval. Then from here to here, we're moving in the negative direction, but then by this point, our slope of our tangent line is flat. We've come to rest right there for an instant. So we are at rest at that moment. Tangent slope is 0. So we're moving in the negative direction, but then slowing down until we reached rest right there. But then we immediately pick up speed again in the negative direction. So by this point, tangent slope is negative once again. We're moving in the negative x direction by there. So we have a negative velocity by that point. So on this curve here, we see that we're slowing down to rest, but then speeding up again. Slowing down, but then speeding up again in the negative direction. And lastly, we're slowing down to come to rest right there, horizontal tangent. So we're at rest there at the end. Okay, we had a smooth curve here. This is the corresponding velocity curve. Let's look at an example that's not smooth, an example that has corners in it. There we are. Just like before, let's start by identifying some different segments. Well, we've got a corner right there. You see what I mean? How there's this sharp transition in the motion right there. Where else do we see a corner? Here, here, and here. Sharp transitions, not smooth parts of our line. We'll see what the consequence of that is. So those are definitely transitions. How about right here? This segment is straight line, and it becomes a curve right there. Then the curve changes from curving this way to curving that way. Then we've got a straight line here, starts to curve, starts to curve. Okay, we've got our segments identified. Starting from the beginning, we have on this first segment, it's a straight line, so we've got a constant velocity, positive velocity at the beginning, positive velocity there at the end if we're looking at this segment. So a constant positive velocity over that segment right there. But then something funny happens. Over this segment, we see it's also a constant positive velocity. Our tangent line looks like that right there, and our tangent line looks like that right there. So constant positive velocity again, but we can see that we're moving faster here than we were on this segment. This is kind of a shallow positive slope, then suddenly we transition to a steep positive slope. You've got a sudden change in velocity right there. The velocity jumps from this value right up to that value. There's no smooth transition. So over this segment here, we're moving very fast in the positive direction. Just from here to there. Ignore that part. We've got a discontinuity. At this point, the velocity jumps from a smallish positive value to a large positive value. That's what our corner is telling us. There's a sudden, sharp change in the velocity. Okay, from here to here, velocity is constant large, and then from here to here, we see that it's slowing down, because by that moment right there, the velocity is 0. We came to rest right there. So down here, we come to rest. Okay, so we're slowing down over this whole interval here, coming to rest. But then we are speeding up again right away. By the end of this curve, we've got this large upward velocity, so we're moving in the positive x direction. So we are speeding up from here to here in the positive x direction. But then once again, we've got a corner. On this segment, we see that the velocity is constant. Moreover, you're at rest. The horizontal line here means we are at rest this whole time. So from here to here, the velocity is 0. It jumps suddenly from this positive velocity down to 0. It's another discontinuity. Our line here is not continuous. It jumps from there to there. That's what a corner means. Continuing over here, we start from rest and then we're speeding up in the negative x direction. So by this point, we have a large negative velocity. So by here, we have a large negative velocity. We're speeding up in the negative x direction. But it's a corner, so we know we're going to have some kind of discontinuity. Over this segment here, it looks like we're starting from rest again. This is a horizontal portion, meaning we're at rest. And then it's speeding up in the negative x direction. Actually, this segment here looks pretty identical to this segment right here. We're just going to repeat the same shape. We're starting from rest and then speeding up in the negative x direction. So by the end, we have this negative slope of our tangent line. Starting from rest, and then by the end of that segment, we are moving in the negative x direction. So this funny corner shows that we have a discontinuity again, as if we were moving quickly, then suddenly slammed to a halt. Moving quickly, slammed back to rest up here. Kind of like over here, we were moving quickly in the positive direction, and then bam, we stopped moving, and we were at rest this whole time. Sudden, sharp transitions, like collisions or hitting a wall. That's what those corners mean. Okay, here's our sharpest corner yet. We're moving in the negative x direction, but then suddenly something totally different is happening on this segment. It shows that we're moving in the positive x direction right there, and then coming to rest at the end. Okay, well, we can put that part in. That's easy. We're coming to rest there at the end. But it says that at the beginning of this segment, we're supposed to be moving in the positive x direction, although a moment ago we were moving in the negative x direction. So we jump suddenly from a negative velocity to a positive velocity. We jump from a negative velocity to a positive velocity, which then slows down to rest. Here's a big jump from that negative velocity right up to that positive velocity, as if it were a baseball that was hit by a bat, moving in one direction, then suddenly changes to move in the opposite direction, moving quickly one way, then quickly the other way. Fast negative, then to fast positive. Each one of these corners then corresponds to a discontinuity. It's not entirely realistic. All real motion is smooth in some sense, but when you have sudden transitions, it can look sharp, look like you have a discontinuity on your graph. Okay, I've got an example for you to work out. Copy down this position versus time curve and draw out the corresponding velocity versus time curve. Start by identifying your segments, break it apart into segments, and then work one segment at a time. Pause the video. Ready? All right, here's the result.